Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get into lesson 8.2.1. For this lesson, we are going to learn about when you conduct surveys. In order for the results of your survey to have value and merit, it's really important that you go through a certain number of steps to ensure that your sample population that you are surveying totally represents the whole population. And this is not easy to do. So that's what this lesson is going to be all about, is the different ways that you can sample a population and the best way to do it to ensure that the results of your sample are as accurate as they can possibly be, because the people in your sample have the same demographics as the people in the total population. So let's get some different vocabulary terms here. First of all, the population that we're referring to is the population of all the people in a given area. For instance, if we were going to conduct a poll asking questions about people in Loomis, about Loomis issues, then the city of Loomis, everybody that lives in Loomis is going to be the population. But finding every single person to ask them the question is very, very difficult. So drawing on what we learned about experimental probability and theoretical probability. Remember back when we were talking about, if you can't figure out what the theoretical probability is, if you do an experiment, the more you do the experiment, the closer your experimental probability will come to the true theoretical mathematical probability. So with that in mind, we want to choose to survey people, but we're not going to survey everyone. We're just going to do like an experiment where we take a sample of the people. And the more people that we survey in the sample, the closer our results are going to be to the true population. That is the essence of what we're getting at with this particular lesson. So the sample is going to be a portion or part of that total group that you're interested in surveying. Now, in order for your sample to really be, what's the word I'm looking for? I guess representative of the total group, you need to make sure that you pick people carefully. So by referring to it as a representative sample, we're saying that all of the subgroups or percentages that are in the total population will be represented in our sample population. For instance, if in the town of Loomis, if we have equal numbers of men and women, boys and girls, then our representative sample should have equal numbers of boys and girls or men and women. If we've got, say, 90% of the people are Caucasian and 10% are African American, then our sample should have the same ratios, the same percentages. So that's the hard part, is making sure that you get every single subgroup represented with equal portions of that subgroup within your representative sample. And then the last term, it occurred to me that there's this term generalize comes into one of the questions later on. So I want to make sure everyone knows what that means. To generalize is to make a broad statement by inferring from specific cases. And so that's basically what we're doing here, is we're going to find out information about the greater population by taking a small representative sample and taking all of the responses from those specific cases and then projecting that onto the greater population. So while we might only survey 50 people, and there might be 5,000 people who live in Loomis, if we've got a truly representative sample and we find certain results for those 50, then we should be able to apply that to the greater population in the same way that we take experimental probability and apply it in that context. Okay, so let's get moving on this. If you want to know what a bowl of soup tastes like, do you need to eat all of the soup in the bowl, or can you just try like a spoonful? Just a small sample will tell you what the taste is. So that's kind of the idea. That's a very good analogy for how you just take a sample of the overall population. You don't need to ask everybody a question. You could just take a representative sample, and that should give you the results that you need. When you conduct a survey, it's not usually possible for you to survey every single person in the population you're interested in, such as all the female teenage shoppers or all the students at your school. Instead, statisticians collect information about a sample of the population. However, finding a representative sample is not easy, as you will see in this lesson. All right, so as the director of the class council, Raymond would like to survey a few of the students about their interests. Raymond analyzes the results. When he does this from the survey, he wants to make claims about the interests of all the students in the school. So keep in mind, he knows he can't ask everybody in the school the question, but he wants to get an accurate, he wants to be able to make this inference about the entire school population. So let's look at some of these different situations. If he were to survey only students at class council, for example, it might be hard to make claims about what all students think. Not every student at school is interested in being a part of class council. So students who are on the class council may not have the same social interests as some of the other students. These are the people that are more interested in working to make the school a better place. Whereas you have some students who are not as interested in that and just want to play sports after school for the sports team. Or some students that aren't really interested in getting involved, and they just like to do their own thing, go home, do their homework, and then play at home. So, just because you're in the class council, you might have, just different interests than other people. So you need to broaden the sample size. So if Raymond wanted to generalize the opinions of all the students at his school, would it make sense to go to a grocery store and survey the people there? I'm going to go ahead and have you pause, read through these questions, and formulate your thoughts. And then when you're ready to move on, I'll uncover what my thoughts are. We'll talk about it a little bit, or I'll talk about it a little bit, and then we'll move on. So go ahead and pause. Okay, welcome back. Do you think that the grocery store is the best place to survey people about issues at school? I'm going to say absolutely not. People at the grocery store are pretty much adults, mostly. They're certainly not filled with students from the school, so that wouldn't be a good representative sample. If you wanted to generalize the opinions of all the students at a school, would it make sense to ask all of his friends at school? Okay, in this situation, that's better than the grocery store, but his friends probably have the same interests as him. Similar to the whole class council thing, everybody that's in like a circle of friends tends to like the same things. And you might not hang out with people that don't have the same interests as you. So just interviewing your friends, I don't think that's a good representative sample. So his friends may not be diverse like the school population is. And then if you wanted to generalize the opinions of all the students at a school, would it make sense to ask every third person who enters the cafeteria at lunch? I actually think that's pretty good. Most of the students go and eat lunch, and if you're doing every third student, then you are randomly choosing people. It's not like you're picking. If you go out and you just walk up to individuals, there's a certain amount of bias. You may not want to walk up to a person that you don't like, but it's important to include everybody in these surveys. So if you just say, I'm going to choose every third person, whether I know them or not, whether I'm friends with them or not, then that's going to be the most random. So that's probably the best of the three situations, is C. Okay, so there are a variety of ways to choose samples of the population. Every sample has features that makes it more or less representative of the larger population. For example, if you want to represent all the students at your school, but you survey all the students at school 30 minutes after the last class has ended, you're likely to get a disproportionate number of students who play school sports because they would have already left. Uh, wait, is that what it's saying? But you survey all the students after the last class ended. You're likely to, you're going to get a disproportion of students who hang out after school to play sports or other after school sorts of activities. So the people who go home immediately would not be included in this survey. And so you're not going to get a really great random sample. So different types of, I forgot to highlight one of these guys. I'm going to highlight this guy right now, right there. Okay, so if you ask the opinion of the people around you when you have then you have used a convenient sample. It's called a convenient sample because it's a lot easier. Convenient samples are easier, but may not be wholly representative of the school population. Once again, the people who are around you are going to be, like if it's a school like our school, K through 8, the people who are around you most of the day are 7th graders and 8th graders. So you're not going to get a chance to ask kindergartners, 1st graders, or 2nd graders. So this falls in that same category as like friends or people in the student council. It's not the best representative sample. If you email people or create some sort of a questionnaire online, you're using a voluntary response sample. Why is it called voluntary response? Because you can't make people answer. So you're likely to only get a few responses, and those that you get are people who are interested in providing feedback. It could be a representative sample, but there's no guarantee it's going to be representative. And then the cluster sample. This one is one I actually like the best. You use a cluster sample. If you first divide the students into smaller groups so that each smaller group represents all the students at your school, then you randomly select one or more of these groups to sample. You might have, or how might you divide the students at your school into groups that each represent the school as a whole? Okay, so, I haven't told you to stop and pause. It would be good if you'd pause and just formulate your own thoughts before you start listening to what I have to say on it. But if you just want to listen to me and write it down, that's fine too. So this is what I said. I said you could divide people by their grade level, by their ethnicity, by their gender, or their participation in sports or honor roll or anything else, okay? If it's done properly, this is the most representative type of sample. But the key is not, you don't want to have a group of 7th graders and a group of Hispanics and a group of women and a group of soccer players and then choose those groups. What you want to have ideally is in your cluster sample, you want to have a properly proportioned number of students in each grade, their ethnicity level. Like if 15% of the students at our school are Hispanic, you want to have 15% of your group be Hispanic. If 2/3 of the students at our school play sports, which we know they don't, but if they did, then you'd want 2/3 of the students in your representative sample being athletes that play sports. So this is the idea that's going to make your sample a truly representative sample. Okay, so please pause the video. You might want to, I don't know if you want to write all this down or just read through it and jot a few notes for each one of basically what we're doing is this. This is the method of sampling, and this is the population that you would get. And, we're trying to determine whether or not it would be a representative sample of your particular school. So go ahead and pause, read through them, formulate your thoughts, and then unpause it, and I'll go through and give you my thoughts. Okay, so call every 100th name in the phone book. Well, that's good for random, but it only gets the people who have their phone numbers listed in the phone book, and I don't know that everybody is even in phone books anymore. That's something that we used to have when I was growing up. So yeah, so you're missing the people who have unlisted phone numbers in this particular situation. How about this one? Survey people who come to the Vote Now booth at the high school football game. Well, does everybody go to the Vote Now football booth or a Vote Now booth at the football game? I would think a couple of things. First of all, you're only going to get people who go to football games, and you're only going to get people who are interested in local politics or local issues. Ask every 10th student entering a high school football game. Well, once again, that's good for random, every 10th student. However, you're only getting people who are interested in going to those sports activities. Haphazardly survey students during the morning break. Well, haphazard isn't really random. I'm not sure that's the best. And then people in your morning break, once again, those are people that have the same break schedule as you. So, you know, we don't see any of the kindergartners or first graders or fourth graders during break times, so that you wouldn't get their opinions. Text response to an online instant poll. Well, okay. When that's voluntary, some people aren't going to respond, but then at the same time, you're excluding anyone who doesn't have a cell phone. So the people that would be the actual population here would be people with cell phones. Hand out surveys in the library before school. Well, how many people do you know that hang out in the library before school? So this is only going to get those people. And then this is one that I actually kind of like the best here. Survey all students in period 1 of English classes. If this were high school, everybody has to take English. And they break everyone up. I mean, if they had like an honors English and a remedial English, then you'd have to make sure that, you know, you're not just choosing the honor students. But still, you know, if everybody has to take English class, and then you just go into every period 1 English class and just ask the people, then you should get a pretty good representative sample of the school. So I put a smiley face there. I like that one the best. All right, so this is an interesting one. When you're doing a survey and conducting a study, part of the scientific method is for scientists to try and rip your argument to shreds. It's a horrible, horrible business to be in if you're trying to get a study published and you know it's going to go under a peer review, and people are going to try and prove you wrong. That's how science works, is they're constantly trying to prove you wrong and trying to punch holes in your theories. And if they can't prove you wrong and they can't punch holes in your theory, then you've got something and people are going to study it a little bit further. But, you know, don't take it personally if you ever go down this road and a bunch of people start criticizing your work. That's what they have to do for it to be truly science. So let's look at this study. A study at the University of Iowa in 2008 concluded that children that play violent video games are more aggressive in real life. Children aged 9 to 12 were studied to determine how much they played violent video games. Peers and teachers were asked how much these students hit, kicked, or got into fights with other students at the school. So I would like for you to pause and read through each one of these questions and formulate a response for each one of them, just like we did in the previous pages. Unpause when you're ready, and I'll say you've unpaused now. So can you legitimately conclude from the study that teenagers who play violent video games tend to be more aggressive? Is this study about teenagers or is it about children? I would say no. They did not study teenagers. They only studied children. So no, I mean, if you're drawing conclusions about teenagers from this study, the scientists are going to rip it apart because you didn't study teenagers. Can you legitimately conclude from this study that children ages 9 to 12 who play violent video games are more likely to commit violent crimes? They weren't studying violent crimes, so I would say no. They were studying behavior, aggressive behavior in real life, not necessarily a violent crime. For C, can you legitimately conclude from this study that children ages 9 to 12 tend to hit and kick more in school? Well, that's another one. The focus is kids who play violent video games, not all the kids. And so you're not going to be drawing any conclusions about the general tendencies of 9 to 12-year-olds as far as kicking and hitting is concerned. This is focused on the students who are playing violent video games. And then the last one. This one might be a little tricky. Can you legitimately conclude from this study that playing a lot of video games will cause 9 to 12-year-olds to become more violent at school? It seems like it. However, there's one thing to consider here. Cause and effect. Do we absolutely know from this study that the playing of violent video games resulted in students wanting to be more aggressive and kick and hit? Or could there have been a reversal? Could there have been a situation where students who tend to hit other people and are more aggressive prefer to play violent video games? I mean, we don't know what the cause and effect is. Maybe they're playing the violent video games because they already have that predisposition to be aggressive and hurtful of other students. So conducting a survey, I mean, I can't tell you the number of times I read through surveys when I was doing my master's programs and reading through studies, I should say, where you would have one group that would draw some conclusions, and then some other groups would do a follow-up study a couple years later, and they would completely come up with different conclusions. And so it's ever evolving, you know, when we're doing studies. And it's not easy to draw conclusions. You just do the best that you can, and you go through the study and then give other people a chance to look through your work and see if they agree or disagree, and hopefully they'll explain why they agree or why they disagree. All right, here's the last part. Oh, goodness gracious, how much time am I taking? Oh my, I'm taking way too much time. Oh well. Well, we got to get through it. We got to get through it. Problem number 33. It says, Addie was helping children in kindergarten class learn to read. She was curious how old the typical child was when they entered kindergarten. It was not practical to look up the records for all 100 students, so on the first day of school, she took a sample and she asked the parent of the first 15 students to be dropped off at school how old they were in months. This is the data. Now make an inference, which is a statistical prediction of the mean age. In other words, find the mean of this data. I know you know how to find the mean of data, but I want to show you a trick that is going to make your lives much, much easier. So I hope you don't mind this video going a little bit longer than usual, because I think this is going to be beneficial to you. Now you know that you're supposed to add up all these numbers and then divide by the number of numbers. So the sum of the ages, and then there were 15 students, right? So there's a symbol for finding the mean in statistics. It looks like that, kind of like a U with this big long line there. So the total sum of all those numbers was 989 divided by 15 would have given you the answer of 65.93 repeated. Now, the biggest problem that we have when we are, when we are trying to do the mean is losing track of these numbers. So 67 plus 61 plus 69 plus, and then if you lose track of one of those numbers, you make a mistake and you don't realize you lost track of a number. You don't realize you made a mistake. So I've always told students, I recommend you do it 3 times. If you get the same answer every time, you could not have made a mistake. It's impossible. You will not make the same exact mistake every single time. If you get a different answer each time, then obviously you're making mistakes. So I want to show you a process. Go to your Google Drive, hit New, then go and open up a Google spreadsheet. Just open up a blank one. What we are going to do, and let me shrink this guy down a little bit. I better shrink this guy down a little bit, move it over. I should have had this all prepared in advance. I'm so sorry. All right, but it's going to be worth it to you. Okay, you ready? What we're going to do is we're going to take each one of these numbers and we're going to put it in a cell. The benefit of putting it each in a cell is that you will see, oh, see, I made a mistake there. I can go back up and I can fix it. Whereas if I'd punched that into the calculator, I may not have seen that mistake. 72, 71, 65, 67, 67 again, 57, 68, 71, 72, 61, 59, 62. Double check to make sure that all those numbers are correct. 61, 72, so remember, maybe do it backwards. 68, 57, 2 67s, a 65. So okay, those are all accurate. Also, notice how these are numbered, these cells. So I know I had 15 numbers there, 1 through 15. Yes, that's in the 15 slot. Now is where I'm going to expand this guy back out. And I'm going to use this function right here where it says to take an average, okay? So what I'd like for you to do is I'd like for you to click on this, drag it down, and highlight all of those. I don't know how easy this is to do on a Chromebook, but and your home computer, hopefully you have this ability to left click it and drag it. Now that all of them are highlighted, now I'm going to go up and I'm going to hit this button and I'm going to hit average. Now there are different types of average. There's a mean and there's a median. I'm going to click average here and it's going to say equals the average of cells A1 to cell A15. And once I agree, yes, that's what I'm looking for, I'm going to hit the enter button and it's going to give me the answer 65.93 repeated, which is precisely the answer that I got by using my calculator. But you didn't have to worry about adding everything together and then dividing by the number of numbers. You let the spreadsheet take care of it for you. Now, one other thing that's good about this, I'm going to copy this. I'm going to paste it here, is you can put this in order from least to greatest to find the median as well. If I right-click everything here and it says sort range, click on that. From A to Z means from least to greatest. So I'm going to sort it from least to greatest, and now look, it's sorted from least to greatest. Unfortunately, we do not have a button up here to find the median, or if there is one, I haven't found it. Luckily, what we can do is this. We can take this language right here, and we can use the same thing, but instead of average, write the word median. So I'm going to say is equal to the median of cell, what is this? Cell C1 colon to C15, and our median is 67. Now, if you look at this, you know how to find the median, right? What's the eighth number down? 1, 2, 3, 4, 5, 6, 7, 8. There it is. There's a 67. That's your median. Using these spreadsheets is going to be a lifesaver for you when we do the Ms. Pac-Man project, because you're going to be taking the scores from every round, rounds 1 through 4, and you are going to find the mean, median, mode, and range. Use your spreadsheets to help you with all of that. I think that's it. That is our lesson, and it only lasted 27 minutes. I'm so sorry. Tomorrow, I'm going to be much quicker with all of this. Get back into my groove and try and turn this into a 15 to 18-minute video at the longest. So, all right, good luck with the homework, and let's see. I don't know if we're going to have a check for understanding today. Maybe we'll have one tomorrow. All right, take care. Bye.
Hey, feeling